Happy Wednesday. I'm meteorologist Brittany Van Voorhees with WCNC Charlotte. I have missed all of you beautiful people watching WCNC Plus. I was in Florida for a few days for a friend's wedding, and I'll tell you right now that I know it was cold yesterday, but it was very nice coming back to dry weather after it being 85 and muggy for 5 days. Well, I guess 4 days, because then we got a cold front too. But we have not a lot of crazy weather in the near term to talk about, but we have a lot of interesting things happening in the weather and space world. So we're going to get to all of that coming up. We'll have some interviews, and we're going to talk a lot of northern lights. So hopefully you're excited for that. First, let's start with what's happening outside right now. Well, temperatures today were almost 20 degrees warmer than where we were yesterday. Our high peaked at 48 degrees in Charlotte. Today we got to 65, so almost an increase of 20 degrees. Right now we're at 59. Winds are relatively light. So there is no forecast, weather-related issues that I would anticipate when it comes to you trying to see the northern lights. We're dry and quiet across the Carolinas. You can see a little bit of cloud cover action up in the mountains. Other than that, we're pretty clear. In fact, with that cloud cover in the mountains, temperatures won't be as cold as they have been the last few days, upper 30s and lower 40s, and that's actually the forecast across most of the Piedmont too. Now, I know that this still seems chilly. And it is, but this is normal for this time of year in Charlotte. Our November averages for November 12th are 40 for a low and 64 for a high. So that's exactly where we were today. That's exactly where we're going to be overnight. But tomorrow, we actually get a touch warmer than where we were today. Most spots are nearing 70 degrees in the Piedmont. Mountains are going to be a little bit cooler in the low 50s. So really nice weather over the next few days. The one thing that we're not going to be tracking is any kind of rain. And I know we say this all the time when it comes to the forecast, but this is kind of a 1-2 punch, right? Got to take the positives with the negatives. The positive here is that if you have outdoor plans over the next few days, you're good to go. In fact, temperatures this weekend will be even warmer, some spots close to 80 degrees. But on the other hand, we are still lacking rainfall, and we haven't really seen any substantial rainfall since last week when our U.S. drought monitor came out, and we will get an update on that tomorrow at 8:30. So we'll have that update for you throughout the day on WCNC Charlotte and on WCNC Plus, of course, during our 6:30 streaming show, where you're already here. So you know where to go if you're watching this right now. Now, as we look at the long-range forecast next 7 days, again, you saw that change or chance for rain, 20% is our maximum. We're looking at very, very limited, if any, accumulation over the next week. But where we are going to see big rain chances is actually over on the West Coast. You can see all pretty much of the state of California up toward Washington State and Oregon. Looks like a big atmospheric river sets up. You can see a lot of substantial rain there. We don't get a lot of rain in some of these areas, of course, and you can see a lot of pockets there of 3, 4, maybe even 5 inches. So make sure if you have friends or family in those areas, they're keeping a very close eye on the forecast. So we are going to talk a lot more about the space weather forecast, but I do want to just kind of briefly go over some of the changes that we have seen, especially if you got to run. But if you don't, make sure you're staying here until 6:58 when we're done. So we are still under a G4 severe watch. That, of course, is the level 4 out of 5. That has been expanded into tomorrow. That's one of the new updates from the NOAA Space Weather Forecast Center. There were 2 coronal mass ejections yesterday. The third of the 3 that were expected have officially arrived. This new CME is a lot faster. It's also not as strong as the 2 that occurred yesterday. Those were about 8 times stronger than normal. This one is about 5 times. That does not mean that we won't see any color. That just means that the magnetic field is not as strong as the one that happened yesterday. So even if we see color, maybe it's a little less They're, of course, going to continue to watch the forecast. And right now, one of the things they are watching is that the magnetic field is pointed in the same direction as the Earth's magnetic field. And similar to two magnets opposing each other, that could create issues when it comes to seeing some of the colors. But let's talk about the positives. Let's say that we have perfect conditions for this G4 to happen. And maybe, again, it's not as good as yesterday, but it happens nonetheless. Possible viewing on the horizon is going to be mainly north of the Carolinas. So if you are in the Carolinas, you'll most likely need to use your long exposure camera. Meteorologist Chris Mulcahy actually put a really easy explainer as to how to change your iPhone and Android settings to this if you are using a cell phone. Of course, if you have a regular long exposure camera, no worries there. And that, of course, is looking northward into the horizon. I don't anticipate, again, any clouds, any big chill in the atmosphere, so we're really not going to see anything forecast-wise that would allow for any major issues. But again, it's really going to depend on how strong this magnetic field is. Even before this, if I've learned anything about space weather forecasting, is it is even more difficult than regular weather forecasting. But the Space Weather Prediction Center, of course, from NOAA is going to continue to monitor these changes, and we'll have updates again throughout the evening. So, of course, we'll have those here on WCNC Plus and also on WCNC Charlotte coming up at 11 o'clock, especially if we're able to see some of the gorgeous color we had yesterday. So pretty much now until midnight would be your best time to see it if you can. The reason why, the moonrise happens just after midnight, so that's kind of our last time period. Dark locations away from any light pollution, it's the same thing we talk about anytime we're trying to see, the meteor showers, anything outside, that's the best thing to do, which does mean that if you live in Charlotte City Center, you're probably going to have to find some dark places because we got a lot of light pollution here in the city. And again, those long exposure pictures, long exposure cameras, or setting up your night shots and your long exposure shots on your smartphone. So there's a lot of ways to set yourself up for success to see it, but again, there's no guarantee at this time, and it is expected to be a little bit weaker if it does happen compared to yesterday, so I wouldn't expect the colors to be as vibrant or anything of that nature. But again, at least the weather looks pretty fantastic, honestly. Overnight lows tonight, most spots in the lower 40s, daytime highs near 70 degrees. We will see a bit of a chill Friday morning with a really weak system passing by, so that's the only morning I'd be concerned about some areas of patchy frost. This weekend looks fantastic. Temperatures skyrocketing to the mid to upper 70s. A lot of really nice conditions in the afternoon. The one thing I would watch out for is Sunday. Could be a bit on the muggy side because we have a cold front coming through, and that's why our low, you can see there's in the upper 50s. Now, muggy again, relative for this time of year, I'm not talking July mugginess, I'm talking November mugginess. And then we are going to see a brief cool down behind that cold front. You can see early next week, highs and lows back into the 40s and 60s respectively. But if you look at the 7-day forecast, I want you to look at that average at the very bottom of your screen. 40 and 64 respectively. So even with that cool down early next week, we are still looking at temperatures above average for this time of year. We will be back in about 2 minutes to talk more about what's happening forecast wise, and of course a lot more on the Northern Lights, so don't go anywhere. everyone, meteorologist Brittany Van Voorhees here with WCNC Charlotte. We are back in action, and we have a lot to talk about today, but a lot of it is going to be centered around the gorgeous northern lights that we saw yesterday in the Carolinas. So it would, of course, was a very, very vibrant picture, videos that we saw. But what's interesting is, the conversation around what happens in our world right now, I feel like a lot of the times is centered around this, right? Smartphones and social media and things like that, and how easy it is for us to take pictures and videos, right, and share that with each other. Well, this was actually a conversation when it came to why are we seeing the aurora borealis more often, right? Yes, it is sometimes, or it is relatively rare to see such beautiful colors 3 times in the last 18 months like we have here in Charlotte. But Chief Meteorologist Brad Panovich posted a very, very interesting social media post, and I do want to bring it up, is that a lot of this has to do with not just the fact that we're seeing this more, but that we're talking about it more. Think about anything. I think I've seen social media comments about that when it comes to like plane crashes recently. Are they really happening more? Or is it just the ease of the technology and the fact that we can share them? Well, a lot of what happens in our world is the ease of being able to share them. And so one thing that Chief Meteorologist Brad Panovich pointed out was about understanding the sun and how it works, right? So there are 11-year sunspot cycles, and these are in areas of maximum and minimum activity. So about 11 years or so ago, we saw one of these cycles occur. However, it was a little bit weaker than the one we're in right now. That was cycle 24, and currently we're in cycle 25. So think about it. If we had a minimum activity 11 years ago, that means our last time we saw maximum activity was 22 years ago. All right, it's 2025. I want you to think back to where you were in 2003. We did not have cell phones the way that we do now. We didn't have iPhones the way that we do now. The first iPhone, at least for myself, I remember coming out around the time I was in high school, which was 2007, 2008. So there's a lot of change that has happened in the way that we use technology. So now that our cycle is more strong, right? So we're now seeing that opportunity to see more of these colors. We're in a more active cycle, but this is the last time we were in the same activity was about 22 years ago. And so Brad actually posted the solar cycle progression with when the first iPhone came out, when the iPhone 10 came out, and then again when the iPhone 11 or 17 came out. And so again, that doesn't mean every single person in the world has iPhones and Androids, but I think it's the way that we document things, right, and the way that we talk about things is so much more different than where we were 22 years or so ago. So again, the last real time we had a solar maximum of this magnitude wasn't even just 22 years ago. It was around 2000 or even 1990. So Brad talks about this a little bit more in depth in his post. So if you're interested in reading it, of course, you can read that if you would like over on his Facebook page. But I just thought it was something interesting that we definitely needed to talk about. And then something else that we want to talk about, of course, is how auroras work in the first place. So we are going to go to a video here from Dr. Jim Spann. He's a senior NOAA space scientist, and so we're going to talk a little bit more with him about how auroras work in the first place, and then we're going to come back and chat a little bit with meteorologist Claire Fry from WFMY. So listen in.
And then the third aspect of space weather that I'll share is called a coronal mass ejection. And the sun has a corona. It's kind of like the outer atmosphere, and it's comprised of plasma or electrified gas. And occasionally a large explosion will occur on the sun, which will essentially lift off part of that corona. And so it's called a coronal mass ejection. So it ejects that mass off the corona. And if in the line of sight, it strikes our planet, it interacts with our own magnetic field and energizes particles in our magnetosphere, the area surrounding our Earth, driven by the magnetic field, and that can cause major disturbances as well. And radiation disturbances and these large coronal mass ejections are probably the biggest impact, and they can cause problems with communications, but they can also induce currents on power lines, which can play havoc with the electrical grid. And they are also the source of the aurora. So in some ways, the aurora is actually the best manifestation of space weather.
It's really great that we get a chance to talk with you here ahead of this satellite launch, but also after we had such a rare viewing of the aurora here in the
Yes.
Carolinas, because it gave me such a unique perspective now. I have so many more questions for you than I probably would have had before that experience. Let me just keep going on your train of thought with x-rays, if I may,
Okay.
because I kind of tried to self-teach myself during that aurora event here in the Carolinas about this webpage that I'm putting on the screen now for our viewers, the
Yeah.
GOES X-ray Flux 1-minute data page, which I did not have bookmarked until we had that aurora event. So what was it that I was looking at when I was watching that spike here?
So those are two energies or wavelengths of X-rays that are shown there. A lower energy and a higher energy, and basically GOES has a sensor which is sensitive to X-rays, and it tracks it, 24/7. And when a large flare occurs, you'll see those big spikes. And like I said, by the time GOES sees it, since GOES is in this geostationary orbit, the X-rays actually happened 8 minutes before, but we only detect them once they arrive at Earth because it takes a while for light to get to our planet. And yeah, and so those X-rays wreak havoc with communications. They also heat up our atmosphere, which can which cause more satellite drag, and sometimes we have to be careful because so satellites don't drag or slow down so much that they lose control or actually deorbit, which happened with Starlink a couple of years ago. They lost 39 satellites.
Wow.
So anyway, so those are some of the things that X-rays can do, and space weather X-rays can do.
Very, very interesting conversation with Dr. Jim Spann from NOAA. We're bringing in meteorologist Claire Fry from WFMY, and we also have amazing weather producer extraordinaire James Brierton. James, you're actually the one who did the interview with Jim.
And
Dr. Spann.
Yeah, and I call back on that knowledge every time we get one of these aurora events. The other thing that I thought was real interesting, there's still work being done right now to try to capture more data. They're trying to launch more satellites into space because just like when we track weather, Brittany, the more data we have along the path, the better the timing is. And so as you mentioned in the show here, space weather forecasting only goes out a couple hours because we pretty much know when it leaves the sun and when it arrives at Earth. But they're trying to add more of these remote sensing observations in the space between Earth and the sun so that it can better track the radiation traveling through space.
Yeah, and that, of course, is another reason how they know whether or not it's impacting things like our cell phones, all the kind of technology issues that it can cause. Claire, let's bring you in because were you able to see any gorgeous colors last night? I was asleep, which I'm kind of sad about.
I personally wasn't. I was actually in bed, but we got some pretty nice pictures in from our viewers. This one actually just behind me was in Reedsville. This was the aurora scene here. Jamie Jones sent this in. It was beautiful for a lot of people, even just on their phones with night mode. Some people still don't know how to do that, but it's usually just in the top right corner when you go to the camera app and you hit night mode. It should be there, but Google might be able to help you better than I can, with the latest iPhones and whatnot. But yes, beautiful view for a lot of us. Again, hard to see with the naked eye, and I think not only do we have to pay close attention to the space forecast, but there is still a little bit of luck, I think, that comes with this too. I feel like yesterday's forecast, at least the space forecast, was severely underestimated for just how far south people were able to actually see it, and it visibly being able to show up on cameras.
Yeah, and as you mentioned, things can, and I think, James, you said this too, things can change so much when it comes to the space forecast, which is why we keep such a close eye on that. Mm-hmm. In fact, we actually got an update during our 6 o'clock newscast. I'm sure you saw this too, Claire. This is from NOAA Space Weather Prediction Center, talking a little bit about current conditions and how that might change what we see tonight. So I think we're going to go to that video, and then we'll come back to the three of us and discuss a little deeper.
Hello again from the Space Weather Prediction Center. We are still monitoring the coronal mass ejection, those blasts of solar material in the form of charged particles and strong magnetic fields that were directed here towards Earth, and what's transpiring from yesterday on into today. So yesterday we had 2 of 3 CMEs arrive here last night, and they arrived here at Earth with a pretty darn good punch, enough to warrant the G4, the severe storm levels that we did in fact achieve last night. So a lot of the country country got to see the aurora, those northern lights last night. Well, that CMEs have since passed mostly over Earth, perhaps even totally past Earth, but the third CME has arrived. It arrived a short bit ago. On some of the displays you see behind me, that's where we monitor the solar wind environment, where we can tell whether these CMEs arrive here at Earth or not, or are about to arrive here at Earth. They're a million miles away. And then we start to see geomagnetic responses here, like you see on some of these plots here behind me, that give us an idea of just how strong the magnetic disturbances is, so that we can send out the appropriate warnings and alerts here in response. Well, currently we still have G3 and less warning levels out there, and they're continuing into the evening hours yet again tonight because of this third CME that has arrived. And we do have extended our G4, our severe storm watch, into the 13th of November, so into Thursday, as a result of this new CME arrival. Now here's a key element. This latest CME arrived, it's faster than the previous CMEs, and our wind speeds have shot up over 800 kilometers per second. Different kind of talk, just know that that's quite fast. Now that CME is passing over us as we speak, and now the magnetic field intensity, we're trying to get a feel of just how strong that is. We don't know if we're in the heart of the magnetic cloud itself yet, or if we're beginning to see the leading edges of that. Nevertheless, yesterday's activity was 8 to 10 times stronger than normal background levels for a magnetic field. This one is about 5 times stronger. So not as intense, but we don't know where we're at in the stage of the CME evolution yet for this final CME. Also, the magnetic field that I talked about yesterday, it's currently pointed the same direction as Earth's. That's not favorable for escalated geomagnetic storm activity. But it can turn at any point in time. Perhaps it will turn again this evening. If it does, that potential that we have that watch out for a G4 can easily happen again. And that's why we've extended that watch into the 13th of November. So what we continue to do here at the Space Weather Prediction is monitor space weather from instruments that are out there in space and near around our planet here. And this is how we detect and monitor this type of activity.
Okay, first of all, I'm obsessed with that man. I love his explanations because they're so easy to understand. So I took some notes actually when I was watching this when it came out about an hour ago. So I'm going to give some cliff notes if you guys missed that. Update, final CME has arrived. So that was 3 of 3. Still at G3 conditions, which is the level 3 out of 5. They're still under G4 watch, which has been expanded into tomorrow. So that's new. This new CME is a lot faster, which means it might not be as strong. Forecasters will watch it to see how strong the magnetic field is. Right now it's about 5 times stronger than normal. Yesterday's was 8 to 10, so it probably won't be as strong, but that doesn't mean you won't see anything. And if you watch one of his videos from yesterday, he kind of described the magnetic field of the CME and the Earth as like 2 magnets, right? If there are 2 positives, they won't go together. 2 negatives, they won't go together. But if they're pointed different directions, it's easier to see color. Right now, they're pointed in the same direction, so we need that magnetic field to turn around. But those were my cliff notes from that explanation.
I just love the setting he's in, Claire.
Yeah, no,
it looks like he's in a bunker someplace.
I mean, James, we've been to the NWS.
Oh,
That's what most of the offices look like.
Oh, I thought it was interesting that, he said today's was only 5 times normal versus the yesterday's was 8 to 10. It kind of gives a little bit of context on, who and how far southward people could visibly see it,
Yeah, and the fact that they even thought today there was a chance, I know that one of the updates said that there was a chance it could get to G5, and I know we literally said this a few minutes ago. It just kind of shows the uncertainty and how quickly things can change, which is why they use the watches and warnings similar to what the NWS uses, when they put out watches and warnings, is like ingredients are favorable for X, Y, and Z, or X, Y, and Z is already happening. So they kind of use similar language, which I think makes it a little bit easier, at least for us as meteorologists, to understand.
I do find it interesting, with this being such a rare phenomenon, especially for us this far south into North Carolina. I mean, this is what this is the 3rd time this has happened this year.
Yeah, in about 18 months. Yeah.
Very lucky for us, for sure.
Yeah, it really is. And also the fact that people have been able to see them and we've gotten the information out quickly. I think that also just goes back though to like social media and the ability to quickly share things. Because the easier it is to share things, the easier it is to pass them along. So
I'm just sitting here hitting refresh on the NOAA Space Weather page. It cracks me up. This Venn diagram between terrestrial weather and space weather. We always talk about how there's this Venn diagram of how many people like weather also tend to like space, and it's like the same muscles that we're exercising, just instead of looking down from the weather satellites, we're looking out.
Yeah, I mean, you need the same tools, or I guess similar tools.
Yeah, did they say it was moving at 800,000 kilometers per second or something? I was like, I can't even fathom this number.
Something insane. And it's funny because he just like kind of was like, okay, yeah, we'll talk about that later. That's how fast it's moving. And it's like, excuse me, say what? I also
he
think
kind
it's
of wrapped
cool.
it up there. He really quick, didn't he? He said, "Yep, that just means it's fast." I was like, "Okay, too fast for me to comprehend, right?"
Yeah. Yeah, the scale is just too crazy. So I think the moral of the story here is that if you're trying to see the colors tonight, pretty much now through midnight would be best, because after midnight, that's when the moonrise happens, so you wouldn't be able to see it as well with your phone or a long exposure camera. If you have those correct settings, as Claire mentioned, that would be best if you're trying to see those. But other than that, Claire, you said it too. It kind of just takes a little bit of luck to see if we can get a nice little explosion of CME activity.
That's right. And, even for us in the triad, too, tonight, before midnight's best, because we do have some clouds kind of coming in from the northwest, too, that'll probably hinder some of that viewing just after midnight, too. So that's another thing to keep in mind, especially if you're going to be heading out over the next couple of hours or later on tonight, too.
I also find it so interesting sometimes that like the meteorologists and the weather enthusiasts, as James knows, are always asked the most, right, about space weather, and you have to kind of explain to people like this is not really what we study. We can understand a lot of it, we could look it up, but that's not necessarily what meteorology is about.
It's like when there's an earthquake.
It's not exactly our area of expertise, but being the scientist of the station, we gotta do our research, right?
Yeah, that's a very good point, James. Yeah, it's like when an earthquake happens, you're like, well, technically that's geology, but I know a little bit.
Right.
Like I can tell you a little bit about it, but not necessarily. One thing I thought that was funny was that when we were talking about the coronal mass ejection, I had to like almost go back and re-look up. I'm like, I know in general what it is. It's the explosion of the expulsion of the plasma and the magnetic field, but the actual way that it works is way too complicated for me to understand. But I'm like, it's just an explosion of solar activity.
Right, and even how it affects the Earth too is very scientific and kind of goes over my head a little bit too. I definitely had to read up as well too every time we get this rare experience. So.
Yeah. So again, if you guys are trying to catch some of the views, you want to look north over the horizon. Make sure that you have those cameras ready to go. The naked eye is going to be much, much less likely, much less possible. And actually, before we go, if we want to pop up our Weather One computer, the one at WCNC, I do have the little forecast where it kind of shows you where viewing would be most likely based on what's currently happening. So current forecast calls for at a maximum about a 7.67, which is between the 7 and 8. And you can see there we are. We're smack dab in the middle. Have a great rest of your Wednesday, y'all. If you get pictures and videos, send them our way, and have a great evening.